Let's go to problem set 2 and see if there's anything we want to look at. I'm going to bypass question number 1 and refer you to that equation in the textbook. I think we did that last week, did we not?
Is that the one
Change the
on
revenue
87?
equation.
I'm trying to, was it 87?
Is it 87?
I don't know, I just worked here. Yes, page 87. The equation on page 87 is the one you're going to use with that. And again, that's just plug the numbers in and crank them out.
That's problem set 2, problem number 1.
Yeah, problem set 2, question number 1. What I want to do is go to question number 4 for a minute. Problem set 2, question number 4. It takes the same model we had a while ago. Let's write it up here. QD 3422.
Oh my god, she's gonna be layers of things.
42QZ.
I'm sorry, which problem is it?
That was another one. I don't have that one.
That's the equation we were using a while ago.
Yeah.
And you carry this stuff around in a notebook and whip it out at a meeting, and people think you got it together.
They probably think that you don't have a life.
You probably don't if you're doing this stuff. Ask me how I know. Now, we already did, and when the price of Z was 6,100, how many did we sell? Was it 12,958? Is that right?
It's 12,900.
We did that before. Okay. But look at part B of number 4. Part B says, our goods Y and R, are those substitutes for good Z? Remember, we're selling good Z. Are those substitutes or complements for good Z?
Oh, burn.
And here's the deal.
And product R.
Look at product Y.
And product sauce.
Look at product Y up here with me.
Well, it's positive.
If the price of Y goes up, will we sell more goods?
It's a compliment.
This has got a positive sign here, which means that if this number gets bigger, we add more to our quantity. You see that? So when the coefficient in front of Y, what we call alpha Y, when that is positive, the goods are substitutes. And in fact, I'm on page 91 now. We can calculate very quickly the cross-price elasticity, sigma, of Z for Y, by taking alpha Y times any given price of Y divided by a given quantity of Z. This is out of page 91, the equations. I'm just using my notation.
I like your notations better.
I do too. So what would be the cross-price elasticity? Well, they gave us a price for Y, right? They said if the price of Y is $450, so this is $450. Well, let's plug these numbers in. Alpha Y is plus 1.6. The price of Y is 450. And how much Z are we selling? 12,958. Calculators are recommended. 4, 5 by 12, 9.
Point
times
0
1.6.
5 5 6.
I got a cross price elasticity of about 0.056, something like that.
Okay. How many do you want us to do?
2 or 3.
2 or 3, okay.
Again, as long as I can see your work step by step, round it to where it's comfortable. You know? So we got the cross price elasticity very quickly. And there is a set of, I think, 4 or 5 videos called Linear Demand Elasticities that lays all this out in horrendous detail. But it's really very simple. You can look at that basic demand equation. What can you tell me about good R? It's got a negative coefficient. It's a complement. So if the price of R goes up, what's going to happen? We're going to lose sales. How much? Well, how do you find the cross price elasticity? Sigma of Z for R. Same thing. It's alpha R times the price of R over the quantity of Z. So we have negative 1.2. I should have written that as a positive number. Price of R was 120.
125. Is this the price hour 125?
125? I'm sorry.
I think. Yeah.
It could be. I'm just working from memory and I haven't got a lot of it. So, 125, it's 150 divided by, you get a tiny, tiny little number here, right? 0.012. Is it a positive number or a negative number?
Negative.
It's a negative number. And so we know that means
When you plug it in like that, it's just so much easier to understand. Because the book, like
oh, the book is, and again, I'm not blaming the author. It's just so hard to explain this stuff in writing. You want to be so correct. Okay, let's do income elasticity. What is the income elasticity of demand for good Z at the current income levels of $40,000? Same idea. Alpha Z times income over, I'm sorry, not alpha Z, alpha M, quantity of Z. Alpha M is 0.2 and positive 0.22. Incomes are 40,000. And quantity is 1258. About 0.68.
yeah, 0.67, yeah.
Is it a positive or negative number?
Positive.
It's a positive. It's got a positive coefficient. We know it's a normal good, and it's got an income elasticity of 0.68. So we can pull the elasticities out of these linear demand equations, and as long as we don't get uptight about it, it's not very difficult. It's easier with practice. How are we doing so far? What does it mean? 0.68, the income elasticity of demand. Well, let's take a look at that. The income elasticity of positive 0.68. The formula for income elasticity is the percentage change in sales given some percentage change in incomes. And suppose then we got our economic forecasters together and they, put together a WAG model for us and said, we think incomes next year are going to rise by 4%. What will that do to our sales?
It's going to increase sales.
We know this is positive 0.68. So 0.68 equals the change in sales we're going to experience divided by the change in income, which is a positive. I'm just going to write 4 as a whole number. You can write 0.04 if you like decimal points. It's the same thing. So what's going to be the percentage change in our sales next year based on the forecast for incomes?
I have 0.027.
0.027 or 2.72%. If you use the decimal, 0.027. Are sales going to increase or decrease?
Increase.
Increase, because it's a positive times a positive. And so we say, well, if incomes go up 4%, that's going to push us in the direction of about a 2.7% increase in sales. Booyah!
Can it be safely said that any sort of increase in income would always increase sales?
No.
No. Or
For what kind of goods will it not increase sales?
inferior.
Inferior goods. So if you were running a public store over the last few years, let's say in Phoenix, Arizona, how would you have changed the mix of goods that are on your shelves? What's happened in Phoenix for the last few years?
It's hot as...
It's always hot. But they suffered one of the worst episodes of the bursting of the bubble in housing prices. Okay? And so as those housing prices fell, people lost jobs along the way. Construction workers lost jobs. The economy went into a recession, and incomes have fallen. In fact, throughout the country, many families are living on much less income than they did. And if you had a grocery store who was, part of your market, or all of your market was those kind of folks who were seeing their incomes fall, how would that change what you put on your shelves?
You would get more substitutes than more inferior goods.
Good. That's the answer I wanted. You would be changing your mix to have more and more inferior goods because people are going to be buying more of it. You can devote more display space to hamburger and less to seafood and steaks and stuff like that. All right? So you want to be able to take any given elasticity. Let's do another one very quickly. I'm going to make one up here. Suppose we know that the cross-price elasticity between our good Z and good R happens to be plus 1.6. Okay? And we use our spies. And we learn that the people that make good R are expecting to raise their price next year by 6%. What will that mean for us? First off, is good R a complement or a substitute for good Z?
It's a substitute.
It's a substitute. What's another word for substitute in this sense?
Similar item.
A competitor. Good R, whoever makes that, is one of our competitors, because our buyers choose between us and them. If we learn they're going to raise price by 6%, is that good news or bad news?
That's bad.
It's bad news because your
Because that
competitors,
means you have
your
to.
competitors will take
Well, if
advantage
your
of it.
competitors raise your price, then you're going to raise your price so that way you stay competitive, right?
If you're selling Coke and you learn that the Pepsi guys are going to raise their price by 6%, is that good news to you or bad news?
Good.
Good.
Good news.
Good news.
You'll raise it to be,
You may raise it, you may not.
Yeah.
You'll welcome all the old folks who used to buy Coke because they're not buying anymore because it's too damn expensive, and you got new customers. Now, if in fact your competitor is going to raise prices by 6%, and you know the cross price elasticity between you is a positive 1.6, what do you think will happen to your sales? Quantitatively, how much will they increase? And we're back to this. Cross price elasticity is the change in the sales of good Z given some change in the price of good R. Plug in the numbers you know. 1.6. Our sales. And
0.96 or 9.6%.
yeah, I would have positive 9.6. You might have positive 0.096. They're the same answer. Sales of our goods Z could be expected to rise by about 9.6%. That's a darn good piece of news to learn that therefore being forced to raise their prices or, making an error in judgment and raising prices. Now what do we do?
Advertise.
That's right. We wait for them to raise price and we go out and say, did you hear what happened to their prices? Ours are still the same. We say it in a more sophisticated manner, but okay? So the elasticity measurements are useful to us in judging how other things out there, like incomes and the prices of other goods, are going to affect our sales. And in fact, we can quantify it. We know they're going up and they're going down, but now we know sort of how much. Okay so far? Okay. Let's see here. Problem set 3. If I can
We
find
can
it.
do number 5.
On the problem set 2?
No, on problem set 3.
Let me see if I can find it. Oh, that's the one that's empty. Yes, very good. There's nothing like taking an old man, find an old man and kick him when he's down. I understand you're my problem. Different kind of problem here. On problem set 3, it's called a break-even problem. Sometimes called cost, volume, profit analysis. Let's knock that one out. We've had a pretty good meeting of it. Okay?
What number is it?
Problem set 3, question number 1. So we're out of elasticities and we're out of demand equations. This is closer to arithmetic. So here's the situation. You've got a business that has fixed costs of $486,000 a year. Now, what are fixed costs?
Things that won't vary.
Things that have to.
Things that don't vary with sales. Okay, they're pretty well constant. And they may vary a little bit. Utilities, okay, they're usually considered a fixed cost, even though there's a little variation in there. If you had a production facility that was using a lot of electricity in your production line, then it might be a variable cost. But we generally say, fixed costs pretty much don't change. And we have, we're providing a, some kind of, what is it here? Whatever it is you're selling, they don't even describe it. Okay? But it costs you, your cost per unit that you're selling to your customers is $2,350 per unit. So maybe it's one of those little mobile wheelchair type devices or whatever.
Or a hearing aid.
Say again?
Or a hearing aid.
Or a hearing aid. Are they that expensive?
Yeah. Or cataract surgery. I work in a night office.
You're kind of impressive. Because I got a feeling all that's just over the hill. Okay, and it says, suppose you can charge a price for your product of $4,000. That's the situation you're looking at. Let me introduce a term here. It's called the contribution margin. CM. The contribution margin is your price minus your variable cost. Variable cost here is $2,350. Every time you produce another unit, your cost goes up. So your cost varies with the number of units you produce. So your contribution margin is $4,000 minus 2350, which is $1,650 per unit. So every time you sell one unit, you pay for it $2,350. You got $1,650 left that you can contribute towards paying off those fixed costs. So how many of these things do you got to sell to pay your fixed costs? And that's the break even. Break even is fixed costs divided by the contribution margin. Did you round up?
Yep.
Good. You always have to round
Can't
up.
make part of one.
That's right.
Well,
I can't sell part of
you
one.
can't sell it, but you can make it work.
All right. So I've got to sell 295 of these things just to break even. What happens when I sell unit number 296? How much profit do I make? $1,650. Okay? Not rocket science. But if we know this is the basic structure of the business, we start asking questions. Is there some way to bring my fixed costs down? Is there some way to bring my variable costs down? Is there some way to raise price? Ooh, now we're back into demand curves. If I raise price. So I pitched a couple of them at you here. I said, here's a question. Suppose this is your business and your brother-in-law needs a job. And your wife has said, he will work for you. You will pay him $60,000 a year. What will that do to your break-even?
It's going up.
You know you got to sell more, but how many more? What do?
Well, the 60,000 goes into your fixed cost.
Perfect.
Yeah.
Your fixed costs are now $546,000. Then you do the math again. And now your break-even has gone to what?
330.
331 units.
Well, it can be 331 if you click 330.9.
If it's 330 and 0.0001, then you move it up to 331 because we can't produce a partial unit and sell it. So when Joe comes to work for you, that means you've got to sell what, 36 more of those little scooters or whatever, just to keep him in a job. And if it wasn't Joe, it was somebody you were considering hiring, this tells you how much value he better contribute to pay for himself.
Yeah.
So if you're going to come in and be a salesman for me,
You gotta sell.
you don't sell 36 units, you're out of here. In fact, you better sell more than that. But that's just to pay for yourself. And that's just your salary. That's not counting other benefits, etc. So it's called sensitivity analysis. We change some of the factors and say, well, what would happen then? Well, here's another one. What if we thought we could raise the price to $4,350? Never mind Joe, he doesn't work there. We're still at $486. It's going to raise the price to $4,350. I'm sorry?
We chose divorce over hiring Joe.
We'll get you there.
Yeah.
So what's my new break-even? 486 divided by, what's my new contribution margin?
43.50.
No, that's my price. What's my margin?
2,000.
2,000. Remember, it cost me $2,350. I sell it for $4,350. Price minus variable cost, 2,000. So, what did that do to my break-even? 243 units from 295. That's what I would have to have. Is it reasonable to raise the price to $4,350? I wonder. Well, what price elasticity of demand does that imply? So, what I'm saying is, when your price was $4,350, 4,000, you had to sell 295 units. But if I raise my price to $43.50, I only need to sell 243 units. What kind of price elasticity of demand is that between those two prices? Is my math off there?
I have 4150.
Is this right?
That's what I got.
Okay.
269.
269, 350, and
4175, yeah.
4175, okay. I got a mistake in the paper here, but have I done the rest of it?
Two point-
2.267.
I have 2.33.
Yeah, that's pretty good.
Yeah, 2.26.
2.30668.
I'm going to call it 2.31.
Yeah, that's what I have.
Okay, what's your Is that an elastic or inelastic demand?
That's elastic.
Elastic is greater than 1. In fact, it's pretty elastic. Okay. So then if I went out and did a little research, or I found some studies that had already been done on my kind of product, and they said, in fact, the price elasticity of demand for your kind of product in usual price ranges is about 1.26. Be good news or bad news?
That's, that'd be good news for
The
you.
demand is more inelastic than we need. That's good news. Remember, the smaller the number, the more inelastic the demand is. They're willing to pay for it. They got to have it. So that would say, like, yeah, maybe that's a pretty good idea. Maybe we can get away with that price hike. Okay? Do you have other concerns, questions, issues? Does anyone recall when the midterm is?
The 20.
23rd.
Is it the 20th?
I don't
We have one more meeting before
Yeah,
that?
we have one more meeting before this.
18th.
The 25th is the exam.
The 25th is the exam, 25th of February. Okay. So we have one more meeting.
I'm sorry, the 26th.
26th.
26th?
26.
Okay.
Yeah, no, the 19th is the next meeting.
Next meeting.
Yeah, 19th is next meeting.
I will, I'll clean these up and post them as GIFs or whatever images. And I will ask you to look at problem sets 4 and 5. Problem set 4 has answers, as I recall. And problem set 5, I'm still going to work on. Now, having said that, yes, focus on the problem sets to get ready for this exam. Imagine, because I'm not sure how I'm going to do this, we'll decide for the next class. Imagine I said you can have one 3x5 card. Put any notes on it you want.
Oh, I'm all about that.
Okay?
Okay.
That would be the formula, the equations, whatever. Something like that. And Take a look at some of the other materials that are on Angel that I've asked you to look at to study. Things like, if demand and supply both increase, what happens to price and what happens to output? Okay, those are basic things from micro. I can imagine I'll put a few of those, but primarily it'll be the stuff we do on these problem sets. Okay, anything else?
We don't need a Scantron or something like that.
You won't need a Scantron. Okay.
Number 2 pencil, probably.
Yeah, you'll need a number 2 pencil and an eraser, and don't forget your calculator.
It's still okay for us to use our phones or whatever.
Yes.
Okay.
Most of you have an honest face.
Oh, we're here, so.
Yeah, right.
Okay?
Well, let me ask you.
Problems or do we need to bring paper here?
Yeah, is it?
Bring notebook paper with you.
Okay, good.
Blank notebook paper.
Oh.
40 people. Is that big enough?
I'm sorry?
No, I'm just thinking there's 40 people in this class.
I think there's closer to 30
Okay.
now.
Now?